Okay, my name is Gavin Hudgens. Thank you for watching this example of a 3D geologic evaluation of a petroleum area in the Permian Basin. Looking down straight on the map view in the site to begin with, you see the Railroad Commission GIS layers laid on top of the site. The dots are vertical wells at the site, and then the horizontal wells are also shown with their transects. Turning it up on its side, it's full 3D geologic model at the site. The left mouse button will rotate, the right mouse button pans, the center mouse button zooms in and out, and this is on a free distributable player. So once the model is built, it can be distributed to anyone in the company, no additional software on any PC. They're multi-frame interactive visualizations, so by clicking through the frames, you turn layers on. In this case, you just saw the dots turn on. Those show the well locations, the control points for creating the layers at the site. In this case, I had over 400 control points, 400 wells controlling the shapes of these layers at the site. You can see all the horizontal wells are visualized here. I could have put all the vertical wells in too, but it just got a little bit too busy, so I just stuck with the horizontal wells. There's also some green wells in here. Those are wells for which I had a little bit more data. I had some Halliburton shale logs and some Rock Vision interpreted logs for those wells, so they're colored a little bit differently just to delineate them. There's all the control points shown without the layers turned on, and then from all that, a 3D volumetric model is created. It's a 3D volumetric model. This is the stratigraphic column for the model over here. Upper and Lower Sprayberry shown in green, Wolfcamp A and B shown in red. Those are the target shelves for this area. 3D geologic model, you can show any layer you want. You can strip the layers down, build the layers back up, and you can show each layer independently or in combination with any other layer to look at the layers that you're focused on. And again here, looking at the Upper and Lower Sprayberry, Wolfcamp A and B. To open a new visualization, you just go to the browser and launch the visualization. Here we see the same visualization with a slice plane placed through the volumetric model on the south end of the site. Slice planes can be moved anywhere in the site. So here, run it through from south to north, turn it, run it west to east. You can do complex rotations. So again, cross sections anywhere that you want at your site. And this becomes very handy when you want to fly into the site and start doing advanced analysis. So here you can look at this well here and see that it is located in the lower part of the Wolfcamp A. So good, nice way to look in and see exactly where the horizontal wells are completed based on your interpretation of the site. So next we're going to zoom in closer to this area where I had the extra data into these green wells here and start looking at some structure and isopac maps. So here we are looking straight down on the site. Again, these wells, well, 4, 5, 8, those are wells that I had the interpreted shale logs on. Turning it up on its side, we're looking at 2 units here. This is the Lower Sprayberry. This is the Wolfcamp A. And for the purposes of the visualization, there's all the control points again turned on, showing the control points for drawing those layer surfaces. And focusing in on the Wolfcamp A, looking down in map view, this is a combined structure and isopac thickness maps. The isopac thicknesses are shown by color corresponding to this legend over here. So you see this producing one well located in this light blue. That's an area that's between 150 to 200 feet thick. So if our area of interest is over here in the yellow, our area of interest would be in an area 200 to 250 feet thick for the Wolfcamp A. And then the black contour lines that you see here are the structure map lines. And so 4,412 feet in elevation, coming up to 3,460 feet elevation, about a 1,000 foot rise from west to east. You can see it from the contour lines, or you can turn it up on its side and see the structure and thickness in 3D for the site. Here we're looking at the Wolfcamp A, and I mentioned that for these wells we had the interpreted logs just take a look real quick at one of these logs look like. So this is a Halliburton shale log. Halliburton shale logs have many, many different components, many different tracks, and any of these components can be visualized in 3D. So in this case, just took one of those components, in this case pore pressure, and visualized it in 3D. You had the resistivity and gamma log going down the side with the traditional squiggly lines, and then the wellbore itself is colored by pore pressure per half foot calculations, and then the number that you see in the middle is average pore pressure throughout the entire stretch of the Wolfcamp A here. So you see in the lower part of the Wolfcamp A, or in the part of the Wolfcamp A that's deeper, you have pore pressures of 3,100 psi, and as you go shallower, pore pressures get lighter. Up here in well 1, 2635 psi, which is what you would expect to see as the formation becomes shallower. You have less overburden. You expect your pore pressures to get a little bit less. Oil in place is also another calculation that is calculated in interpreted logs. And so here we're looking at oil in place. The colors that you see going down the borings are oil in place colored by barrels per acre per half foot. And then here you have the total barrels per acre throughout the entire length of the formation of the Wolfcamp A. So you can see over here you have maximum numbers of 114,000 barrels per acre. And over here on the low end, 79,000 barrels per acre in the Wolfcamp A. And again, any components can be visualized. This is just a very quick visualization. The color scheme hasn't been optimized, but just to show, if I just hit play, it's going to go through 118 frames showing every component in the interpreted shale logs and rock vision logs for this site. You can also visualize the any ratio of components, various components in the site. So a great way to see the 3D distribution of the components in the site. Once you get to that point, it's good to start going in and looking at the shale logs and coming up with thresholds to start doing some NetPay ISOPAC maps. Some of the thresholds that can be used in the Wolfcamp if you're looking into shale reservoirs include brittle shale, total organic carbon, resistivity, organic shale content, limestone beds, shale porosity, all these different components. In this case, the components that we used were resistivity with a cutoff of 25 ohms, shale porosity with a threshold cutoff of 2%, total organic content at greater than or equal to 2%, and brittleness at 35. So if we see what that looks like, look at a NetPay ISOPAC meeting all of those threshold criteria. You see well 4 here has the most net pay potential. Well 2 over here has the least net pay potential, ranging from 107 feet over here in the southwest down to 33 feet over here in the southeast. And you can see the different thicknesses. A great way to look for sweet spots in whatever area that you're evaluating. From all of this information, a geologic summary is prepared that discusses the data reviewed, the process of the geologic evaluation, the results of the geologic evaluation, which includes the calculated barrels per acre throughout whatever formation you're interested in this case the Wolfcamp A, barrels per acre. And then you look at barrels per acre that are in the target reservoir. So in this case, we're looking for brittle shales. And here you see the barrels per acre in brittle shale. And this is a calculation of the percentage of the oil in place that is in the brittle shale. So in well 8, 50% of the oil in place is in frackable shales. In well 2, 10% of the oil in place is within frackable shales. So I went ahead and mapped that to see what that would look like. And here's what that looks like. The colors are percent of oil in place that is in the brittle shale. So you see well 4, well 10, well 8, those are the areas that would be best if you're looking to frack shales. Well 2, only 10 to 20% of the wells of the oil in place are in the brittle shales, and so it begs the question, well, where is the rest of the oil in place located? Well, it can be in more ductile shales, which would be less optimal, or maybe it's in dolomites and limestones, and you can go back and look at the triple combos, look at the interpreted logs, and see if you can tease out some carbonate reservoirs, maybe a little different completion on this to try to get the oil out from those areas. And finally, going back, you come up with a recovery rate estimates for your units, the type of completion that you're going to have, 2-mile lateral in this case, calculated drainage area for the area, and you finally come up with a recoverable barrels of oil per well for the site. So that's an example of a 3D geologic evaluation in the Midland Basin. Thank you for watching. If you have any questions, please don't hesitate to contact me.